All right, this is video for Algebra 2, Unit 9, Lesson 2 over the standard normal curve. I'm going to do an example explaining how to use the diagram. The diagram you need to be using for all these problems in the unit or in this lesson is going to be right here, figure 2.4. Let me explain a little bit about what this diagram is telling you before we jump into it. So what you're looking at is a data set. In the middle y-axis right here that you see marked in the middle is the mean value. So the mean value of all this data is located right there. So that's the mean. Let me write that down. This is the mean. And so this should make sense, but in a data set, most of the data is going to be bunched around the mean, which is why this curve goes really high here in the middle and then it trails off on either side, because most of the values of the data are near the mean, whereas values that are very far from the mean are less likely. Take, for instance, height. If you looked at the average height of a human, most people would be somewhere in the range here. In fact, exactly these percentages are within each set of values. Now the question is, where are we getting these different marks here, here, and so on, going up and down? Each one of those marks is what's called a standard deviation. A standard deviation is a mathematical measure of how spread out a set of data is. So we see that within one standard deviation above and below the mean, this would be one standard deviation below. I'll change my color so you can see what I'm talking about. This is one standard deviation below. This is one standard deviation above. Within those two ranges, there's 34.1 on either side. In other words, 68.2% of all of the values are one standard deviation below or one standard deviation above the mean. And then the further out you go, the less likely there are to be values in that area. 13.6 as you go from 1 to 2 on either side, and 2.1 as you go from 2 to 3 on either side, and then even less outside of 3 standard deviations. So that's kind of the big idea. So what we're going to be doing in these problems, let me erase everything on my screen here, is we're going to be using this, and I'm going to show you on here how you can use this diagram to get the answers. So let's hop back over to our other screen and let's talk about the questions that they're asking us. These are the way the questions are going to be worded. They're going to give you the mean, they're going to tell you the standard deviation, and then they're going to give you some situation, and you're supposed to calculate how much of a data set would fall in between a certain range. So we need to know what our mean is, we need to know what our standard deviation is, and we need to know what the thing we're trying to calculate is. So the mean here says the mean shelf life is 3 years and 4 months. Let's write that down. I'm going to move that over to my note here to show that we're looking at the mean is 3 years and 4 months. I'll just write that right there. So 3 years and 4 months is the mean value. And let's go back and read the rest of the problem. It says that the standard deviation is 3 months. It says that right here. Standard deviation is 3 months. So every move up or down on my different values here is going to be a standard deviation above or below. So if 3 months is the standard deviation, this mark here is 3 years and 7 months, which is 3 months more than the mean. And then if I keep going, this is going to be 3 years and 10 months. If I go down, this is going to be 3 years and 1 month. And if I go again, it will be 2 years and 10 months. And then I could keep going out here, but we'll see if the problem wants us to find one of those areas. So each of these marks represents right now, for this particular problem, this amount of time. And so I'll read the whole problem now. It says a flashlight battery manufacturer makes a model of battery whose mean shelf life is 3 years and 4 months. That's what we put at the mean in the middle, with a standard deviation of 3 months. We already discussed how we took those 3 months and we made each mark 3 more or 3 less than the previous mark, depending on which direction we are going. Here we're going up, and here we're going down a standard deviation. So we either added or subtracted 3 months based on that information. The distribution is normal, approximately normal. That's just telling us that we're using this curve that we talked about. One production run of batteries in the factory was 25,000 batteries. How many of those batteries can be expected to last between 3 years and 1 month and 3 years and 7 months? So this is key right here, 3 years and 1 month, 3 years and 7 months. So I see that 3 years and 1 month is right here. And 3 years and 7 months is right here. So we are looking at the area in here. We want to know how much of those 25,000 batteries should fit into that. And so we can see these are the numbers that we're going to be focusing on. So we can see that if I take that out, the amount of the batteries that fall into that shaded area is 68.2% of the batteries, because that is the percent that falls under the curve in that section of the graph. That is going to be multiplied by 25,000 batteries, and that will give us our answers. Let me open a calculator here for us. If I can get it to work. Sorry about that glitch. So going back to our problem, we said we had just shown that we needed to find 68.2% of 25,000. And you can see we get 17,050. And if we go back to our answer choices, we see right here, that is our answer choice right here. And so that's how we're getting this number. We're just getting it based on multiplying the 25,000 batteries times the percentages from our charts. Again, the chart we're using is this one. I showed you how to kind of set it up for this problem, but because we are in these two sections, we added these and then multiplied that total percentage times 25,000, which was the number of batteries, and that's how we get this value right here. And all these problems basically work the same way. You look, you find the mean, you find the standard deviation, you set up the curve, you find the sections of the graph that correspond with the problem, and then you multiply those percentages by the total, and that gives you the value that you're looking for. So that should be what you need for this section. Good luck.